Hey, what's up, guys? How's it going? So today I want to put out a little video about pointers in C++. Hopefully this video will help you if you're a beginner to kind of understand what pointers are and how to use them. So for this video, I'm going to be using C++ shell. It's super nice because you can just compile a C++ project on a web page and it's super convenient. So the first thing we need to go over when learning about pointers is learning about addresses of variables. So an address is where a variable is stored in memory. And if I have a variable, like say I make a variable int var, set that equal to 1, and in C++ we can actually access where it's stored. And we do this by the ampersand. So if I write ampersand var, this is going to give me the place in memory where it's stored. So just to show you guys what that looks like, if I do a cout var, and then I go ahead and compile. All right, here on the output, this is a crazy looking hexadecimal number, right? This is actually the address in memory where var is found. So this brings us to pointers. So what a pointer is, it's a variable that stores the address of another variable. So for example, it'd be kind of like saying pointer equals address of var. But we need a little more to define this variable. We need a type, right? So to define a pointer, the type of a pointer is whatever the type of the variable is, and then an asterisk. So this is saying we're defining a pointer called PTR pointer and assigning it the value of the address variable. So that might be kind of confusing, but to help you guys out, let's print out some stuff. So we're going to do cout var, then we're going to cout the address of var, and then we're going to cout pointer. Okay, let's run this. All right, it finished running. So down below, var is 1, the address of var is this, and then pointer is that. So the value of pointer is the address of var. Now let's see where pointer is located in memory, because pointer has an address as well. So you can do cout ampersand pointer. And as you guys can see, the value of PTR pointer is in a different location. So there's a variable called var that's located at this address, and then there's a variable pointer that's located at this address. But the value of pointer is the address of var. So one other thing we can do with pointers is called dereferencing. We can take this pointer and we can access the original value of var1 just by using this pointer. And the way we do that is by using asterisks again and the value or the name of the pointer. So this is actually going to return 1. So let's go ahead and print this out to show you guys. Just going to comment these ones out to avoid confusion. All right, to kind of understand this, we'll first print out pointer, and then we'll print out the value of pointer by dereferencing with the asterisk like that. Okay, let's run this and see what happens. Awesome. So the value of the pointer is the address of where var is located. And then the dereference pointer is actually that 1. So just to keep it really simple, PTR has a value that's the address of var, but then asterisk PTR returns the value of var. So pointer contains the address of var, right? And then we can access the value of var using asterisk pointer. So what would happen if we redefined asterisk pointer to be something else? Well, let's try it. So we do asterisk PTR equals 2. So let's see what happens. Let's cout var, and then let's cout asterisk PTR, and we'll see what we get. We'll comment these lines out. Okay, let's run this and see what happens. So var was 1, right? But then when we redefined asterisk pointer to 2, it changed var and the asterisk pointer to 2. In other words, if you change the value of a pointer this way, you're gonna change the original variable. So the fact that you can change the original value of your variable just using a pointer can be very useful, but it can also be very dangerous. So if you have a variable that you don't want to change, you can always use the const keyword. That will make sure that that variable can't be changed. So if we do that, and then we'd have to define this as a const int pointer because we have to keep the types the same. But if we do this and we run, as you can see, we got an error. So the error was because the read-only variable is not assignable. So you can't go ahead and change the original value using a pointer if you use this const keyword. So let's say in your code you want to allow var to be able to be changed, but not by a pointer. What you can do is you can remove this. So this means that we can change var, but we just can't change var using this specific pointer because it's a const pointer. So for example, if we run this code, it's going to give an error right here. But if we just redefine var like this, run this code, now it actually changes it to 2. So using this const keyword can be really helpful when making sure you protect those variables, to make sure you can't just change them using a pointer. But there are some situations when you would want to change that original variable with a pointer. So let's go back to just our single variable var equals 1. What's really crazy is that even if you pass a pointer into a function, it can still reach outside the scope of the function and change the original variable. So to show this off, so I have my variable var. I'm going to create a pointer, call it pvar equals address of var. And first, I'm just going to create a function called change value. It'll be void. And it's going to take in an int. Then we're going to just add 1. So value plus equals 1. And then we'll do that. So if you guys know anything about functions, you'll know that this function is not going to do anything. It creates a copy of whatever you pass into it, adds 1 to that copy. But since we didn't return anything, the copy is just going to die. Let's run it just to show you guys. If I go down here and let's do cout var, and then we'll change value of var, and then cout var again, run this code. Yeah, so as you guys can see, before the change was 1, after the change was still 1. So yeah. Now the crazy thing is though, if you pass a pointer into this function, so let's change, instead of passing the int, we'll change it to a pointer, int pointer, and then we'll modify what that pointer points to, add 1 to that. Now down here, instead of passing in the variable, we need to pass in a pointer. So I'm going to just pass in pvar, which we defined right here, to point to var. Now watch what happens when we run this code. So if you look down here, var was equal to 1, we passed it through that function, and now it's 2. So moral of the story is, if you pass a pointer into a function, it can still find the original value that it points to. All right, guys, that's it for today. Thank you for watching. Now, if you guys like this tutorial and you want to study a little more, you can check out my website, john9francis.github.io/pointers. And in this website, I go over a lot of things I've learned about pointers. So if you're more of a learner that likes to read instead of listen to videos, you can go ahead and check this out. And if you would consider supporting me in my content creating, consider supporting me on one of the links down below. Appreciate you watching. See you later.